right, so we're going to be looking at, as our first shape, a rectangular prism, right? So again, a rectangular prism is just 6 faces. All the faces are rectangles, all right? One of the ways to think about surface area is to examine what's called a net. So a net is just a flat pattern that makes a prism, okay? If you've ever, broken down a box to recycle it, right, we can, turn it into a flat pattern. So if I were to kind of disconnect all the rectangles here, right? I'd have something like that looks like this. So I've got my 6 faces. It kind of makes a cross pattern. Okay. So surface area is simply finding the area of all 6 of those rectangles and putting them together. All right. Now this is obviously not drawn to scale. All right. But if I think about this as like the front and the back side, so the front is 28 by 12. The back side is also 28 by 12. Okay. This part here would be the left side. So the left side is 28 by 22. Okay. The next one would be the bottom. The bottom is 12 by 22. Okay. And then we'd have the right side. The right side is 28 by 22. All right. And then finally we'd have the top, which is 12 by 22. And again, I did not in any way, shape, or form draw those to scale, obviously. Okay. Now, what's interesting is you've got basically these two things that are sticking out. Notice that they're the same. Okay. They're both 28 by 22. We're going to refer to those two as the base. All right. And on a rectangular prism, anything can be the base. The base is defined as those two faces that are parallel to each other. Well, on a rectangular prism, right, you really have 3 sets of bases. You've got the front and the back are parallel, the top and the bottom, the left and the right. So it doesn't really matter which one's the base on a rectangular prism. Okay. But you'll notice there's 2 of them. All right. So we've got 2 bases. Okay. Now, the middle part we refer to as the lateral area. Okay, that's the faces that are between the bases. All right. Now, you could find all of those areas individually and add them up. Okay, but really when we look at it, it makes one big rectangle. Okay, so what we're going to do instead is we're just going to find this length and multiply it by 22. Okay, now if we look at that, that goes 28, 12, 28, 12. Now, what's interesting about that is, and again, I'm using this front side as my base. It's just the perimeter of that, right? If we think about the perimeter of that front face, 28, 12, 28, 12 as you go around the outside. Okay. Looks like that. 28, 28, 12, 12. So what that really is just the perimeter of that base. Okay. So in our formula, we're going to use capital P to stand for that. All right. And then we're taking that times 22. So 22 is the distance between the 2 bases. Again, I'm using the front and the back side as my bases. So 22 is that distance between the bases. We refer to that as the height. Okay. Now, don't confuse height with up and down. Again, you could take a prism, you could turn it, right, so that different faces are now down and up. So we can't always think of up and down as being height because things can turn, right? Just like if I laid down on the ground, right, my height is still the same. I wouldn't measure from the ground to the tip of my nose or whatever, right? My height's still from the bottom of my feet to the top of my head, regardless of if I'm standing up or laying down. So the height of a prism is the distance between the 2 bases, right? I'm using the front and the back as the base, so the height is 22. Okay, so essentially what I'm doing there is I'm using this formula. Okay, let me clear my screen here quick so I can give you a little bit more room here. Okay, so again, you could go through, you could find each of those rectangles individually, all right? But if you just have an understanding of what we're really doing here is we're finding the area of the base, and there are 2 of the bases, so 2 times area of the base. Capital B is area of the base. Okay, and then that lateral area, again, is those 4 other rectangles. We can find that by finding the perimeter of the base times the height. So capital P is the perimeter of the base. Pen does not want to write very nicely today. Perimeter of base, and H is the height and refer to height as the distance between the bases. Come on, pen. Apologize for my sloppy handwriting here. Holy cow. That should say distance between the bases. What is going on? You know what? Let me re-erase this here quick. Again, if you're listening to this, it makes sense, but don't know why my pen is being so difficult. Distance between, it's a little better. Distance between the bases, okay? So when I want to find the surface area, I'm just going to follow that formula. What I'd recommend you do is you go through and you identify those three things, okay? So the area of the base, and again, it doesn't matter, right? You can use the top, the front, the bottom, whatever. I'm going to use the bottom just because we kind of associate that with it. So the bottom would be 22 by 12. Okay. Come on, pen. So if I multiply that together, and again, you guys can use a calculator if you need to for that, that's 264. Okay. Perimeter of the base. So that's going to be 22 plus 12. And you can do 22 plus 12 again, or you can multiply that times 2. So that's going to be, let's see, 22 and 12 is 34. 34 times 2 is 68. Okay, and then your height is going to be the distance between the bases. I'm using the bottom and top as my bases. So the height's going to be 28. Again, it doesn't matter which ones you use. Okay, on a rectangular prism, because they're all rectangles, you have those three sets of parallel sides. So I just want to take 2 times the area of the base. Two times 264 plus the perimeter of the base, okay, which is 68. Come on, there we go. Times your height, times 28. Okay, so lay that all out first before you grab your calculator, and then just punch all that in at once. Okay, so 2 times 264 plus 68 times 28. That gets you 2,432, and its area, so it's going to be square units, so centimeters squared. There we go, 2,432 centimeters squared. Again, identify the area of the base, the perimeter of the base, the height, then plug it into the formula. All right. Now let's look at a triangular prism. Okay. So on a triangular prism, right, we don't have that 3 groups of bases. The bases are the triangles, right? They're the only 2 faces that are parallel to each other. Okay. So again, we'll start with our formula. Okay. Let's find the area of the base. So that's the area of the triangle, right? So base times height divided by 2, or half of the base times the height. Okay. So our base and our height are that right angle in the triangle. So 12 and 16 are our base and our height. So 12. Let's see, 1/2 times 12 times 16. And again, you can do 12 times 16 divided by 2. I'm just going to do half of 12 is 6. 6 times 16 is 96. Okay, so the area of your base is 96. Perimeter of your base. Okay, that's just the distance around the outside of the triangle. So 16 plus 12 plus 20. Okay, 16, 12, and 20, which is 48. And then the height is the distance between the triangles. Again, don't confuse the height of the triangle with the height of the prism. Distance between the triangles, between our bases, is 10. Okay? So I've got those 3 things, and I just want to plug them into the formula. So 2 times the area of the base plus the perimeter of the base. There we go. Times the height. Okay? So 2 times 96 plus 48 times 10 gets you 672. Come on, pen. There we go. 672 centimeters squared. Okay. Again, area of the base, perimeter of the base, height, which is the distance between the bases. Plug it into the formula. 2 times area of the base plus the perimeter of the base times the height. Okay. And then cylinder. Okay, now cylinder, same idea, but we're gonna adjust the formula for a circle, right? So 2 times the area of the base. Well, the area of the base is, or I'm sorry, the shape of the base is a circle. So we're gonna go 2 pi r squared. Pi r squared is the area of the base. Lots of extra noises going on today. So 2 pi r squared is 2 times the area of the base. Now the perimeter of the base, right? That's the circumference of the circle, right? Perimeter of a circle we call circumference. So that's pi times diameter and then times our height. Okay. So this might look difficult or complicated, but it's basically just the same formula just applied to a cylinders, right? Pi r squared is the area of the base. Pi times diameter is the perimeter of the circle, which we call circumference, and then height. Okay. So 2 pi. Our radius is, we have a diameter of 3, so our radius is 1.5 squared plus pi times our diameter, which is 3, and our height is 12. Okay? And then grab your calculators and just use your calculator to do these calculations. And if we do that correctly, you should be able to just punch this all in at once. Okay, don't do a part, round it. And when you're dealing with pi, the less rounding you do, the more accurate it is. So just put it in all at once on your calculator. And if we go to nearest tenth, we get 127.2 inches squared. Okay. So again, just follow your formulas. I'll give you the formulas. They're on the note sheet that I attached in your Schoology page, right? Follow the formulas. Before you grab a calculator, though, plan out what you're going to put in there, right? Identify that area of the base, identify the perimeter, identify the height. If you're using the cylinder formula, right? Write out the formula with your numbers put in, okay? Then grab your calculator. And remember labels, right? We're doing area, so it's square units, all right?